to be here. Well,
so I just want to say it's not going to be a formal, presentation. So you can ask, questions during the presentation. The goal is to show you the maps and how to use them. For example, for next Sunday, where to go, inside the Eclipse path. That's it. So if you have questions, you can ask them anytime. Okay? And if I am not clear, you can ask, I repeat, no problem. So, first we are going to look at the maps, and then we are going to speak about the Baily's beads, which you can see during this eclipse. So, I'm not going to read the whole presentation. It will be available, so if you want to download it on your computer, then you can read it after. Okay? That way we lose less time, and it can be more interactive. Okay? So, what I just want to say is that before, let's say the 21st century, Eclipse maps were paper maps. Okay? So just on paper, and you had to draw the eclipse path on those maps. So everybody that was going to see an eclipse was drawing by himself the map. Which is why I started to work on this tool to have something that is done automatically. Okay, you can do it for any eclipses. It's nearly instantaneous. You just ask for it, and you can of course zoom in, zoom out, know exactly at what time one eclipse will occur. So it's really completely interactive. Okay, the first maps were available in 2005, so 12 years ago. Okay, so it's fairly new. The reason I also, built this tool is that I knew about the Google Maps that were going to be released before, they were made public. Okay, just for, people know about it, so I should not, hide it. I'm a good friend with one of the two, Google co-founders. Okay, so this is why I knew about it before. So let's go now on the map. So this is the general map of the eclipse coming next Sunday. Okay, so the part between the two, pinkish line, it's what we call the central eclipse path. For an annular eclipse, it's where you can see this ring, around the moon. For a total eclipse, since the moon is bigger than the sun, this path is of course the part when the eclipse is total. So in your case, if you want to see a ring, you need to be between those two pinkish lines. The blue line is what we call the center line, okay? Linea de centralidad, okay? So if you want to have a symmetrical ring, you have to go near the blue line. If you go closer to both edges, so the pinkish line, then the symmetry is not going to be perfect. There will be an offset. The moon will be either on one side or the other of the sun. Okay, so depending on also the aesthetic that you want to have, you can position yourself inside this band. Okay, so outside, so in between those green lines, the eclipse is partial. Okay, so you have no ring. It's going to be a crescent that will be, of course, changing in size. A very thin crescent over there, and a very big one over there. And of course, if you go outside, no eclipse. You just see the sun, like today, for example. The moon is away from the sun. That line, it's when the eclipse occurs on the horizon, so at sunrise, and over there at sunset. So as you can see, you have more or less sunrise in South America, sunset in southern Africa. Okay, most likely nobody will be, watching the eclipse in the Atlantic Ocean. Some people will go to Angola, but Argentina is the best location because of the weather potential. Chile is not as good because of the Andes blocking the clouds, so you have more chance of having clouds and eventually rain. The green lines that you see there, that are parallel more or less to the eclipse path, it gives you the magnitude of the eclipse. It's those are every 20%. So 20%, 40%, 60%, 80%, and slightly less than 100 because it's not total. If it was total, it would be 100. So the closer, you get, the bigger the magnitude is. Often we also, represent the point of greatest eclipse. It's where, in fact, usually, the moon, the sun is aligned with the Earth. Okay, but it has no particular interest. For a total eclipse, for example, it's usually, near that point, it's where the duration is the longest. But duration is not, the most important, in my opinion. But again, for this eclipse, the longest duration is not near this point. In fact, the longest duration is over Argentina. But this is, it depends on eclipses. So now we are going to look at the local, circumstances in Esquel. So on the map, you can always zoom in, zoom out. You have, two buttons. You can also use Street View when it's available. For example, it's available in Argentina. So you can, drag the little, man on the road, and it will show you the view that you can have, from the ground. Okay. Then you don't see well here, but you have a few tools. You have one that can zoom on one particular area. Otherwise, you can use the zoom buttons, but you can also select one area. You can also know the profile of the terrain elevation. So when you click at one location, if the tool is activated, it's going to display the profile of the terrain. I will show later why it can be important. In our case, it's not, because the sun is high enough. But I will show you some examples. And you have a geolocation tool. If you activate this tool, for example, on your smartphone, it's going to locate you. And if, for example, you are driving in your car, it will show you how far you are from the path. So you don't even need to know the coordinates in advance. You could just use your smartphone and wait until, of course, you are inside the path. Okay, so it's possible to do that as well. So I just won't speak much about what's available in the circumstances, because it's very easy. You have the elevation, so the altitude of the sun. It's azimuth. It's always counted from the north. So east is 90 degrees. Okay, south 180, and 270 for west. And a few other values that tells you where the moon is going to touch the sun. Okay, be careful, because those angles, they are counted counterclockwise. Okay, not like a watch. The only one that is the last one. In fact, it gives you the hours. It's just like you're looking at your watch. This is what you will see in the sky. And there's a small diagram. If you just with your mouse go over the events, it will show you where the moon is at that time. Yes.
That clock dimension in the just in the left, in the
yes,
right,
the last, yes,
in the right, like your clock.
Yes. If you see, for example, two.
That is the same as the vertex angle.
Yes.
But measure in another unity.
That's correct, absolutely. It's because for some people it's easier, you know, they, oh, watch, okay, 2 o'clock, they know, because, you know, when you give them an angle, they say, oh, yes, but an angle from where?
I find it good.
Yes.
But didn't you think about including also the vertex angle?
I think I will add a switch.
Yes.
Yes. Yes. Yeah, because also there is one thing I didn't, you know, explain, but because there is a help, you know, you can, you know, click on this link and you will have all the details. But this, you know, position angle is also, you know, counted from the solar north. So the north pole of the sun, and the north pole of the sun is the red mark on the diagram. And as you can see, it's not the zenith. It can be, but it's, in this case, it's not. So you have to know also from where to start. The big advantage of the, let's say, our angle is that it starts just like your watch. Okay, so for most people it's easy. This is why, you know, I did it, you know, that way. But of course, technically for us, that angle is more useful. But for the general public, that one is. Okay. So now, if we move to Facundo, as you can see, we are inside the central eclipse path and very close to the center line. Okay, and before, you know, outside the eclipse path, you only had 3 main events: first contact, maximum, fourth contact. When you are inside the path, you have 2 more events: second contact, third contact. Those 2 events are the start of the ring and the end of the ring. Okay? You see also one thing that, of course, you didn't have on the general map. It's this orange outline. This is the shape of the umbral shadow, the shadow of the moon. Okay? In that case, I should say ant-umbral shadow. The real shadow is a bit angled, but this is the general shape. Okay? And I will show you later that, of course, this, you know, shadow moves from west to east. Okay? So depending on the time, it will move. Right now, I selected maximum eclipse, so this event. So the shadow is centered on the location I clicked on. Okay? If I move my mouse to, for example, second contact, the shadow is going to be there before. If I click on third contact, it's going to be after. And if I click on fourth, it's off, the screenshot. Okay? And you have a couple, you know, more informations. I mean, it's you know, the speed, for example, of the shadow. As you can see, it's quite high. There are no aircraft, you know, that can fly, you know, that fast and for that long. Then, one last thing, for most people it's not useful, but you have another column which gives you the correction that we apply because of the lunar limb profile. Because the time here is given with a smooth moon, okay? Not taking into account the peaks and valleys of the moon. When you take into account those peaks and valleys, you have to correct this time by those 2 values. Okay, we give them only at second and third contact because at first and fourth, for example, you cannot detect it with regular, you know, instruments. There is no way you can, you know, see any difference. The resolution is not, you know, good enough. So there is no point giving those values. There is one last thing I will, you know, speak about later, is also when you click on this column header, it will give you the lunar limb profile. I will show it a bit later. So this is, you know, where you can click. Any questions?
Yes. When you use the profile,
yes,
the lunar profile,
yes,
that means that the time, the duration is short.
It can be shorter, it can be also longer.
Also longer.
Yes.
So, but I thought it means that you take the diameter of the moon as taking into account the valleys.
Yes.
That's right.
And the peaks, yes. Mm-hmm.
No, valleys or peak, but when you receive the light, it means that the light has gone through a valley.
Yes.
Not through a peak.
Of course.
So, in this case, what you are taking into account is a diameter of the moon similar to, from the center of the moon to the deepest valley.
It's more complicated than that. Okay, I'm not, of course, going to give details because it's too technical, but what we do is, when you compute the position of any body in space, you compute it from the center of mass. Okay? So, first you do the computation with the center of mass. Then, of course, the moon is not perfectly round, and its optical center is different than its center of mass. So we correct also, for this. Okay, but the basic computations are done with the center of mass. Okay, it's really technical. I mean, this, for example, with the accuracy that we have now, it's very recent. I started. In the 1960s, you had what we call the Watts profile, but I mean, of course, at the time it was great, but of course nowadays it's nearly worthless. Okay, but the newest data started to come only in 2009, so only 8 years ago. Okay, so the greatest accuracy, only started, in fact, only 8 years ago. So it's very recent. Okay, and there are very few people anyway that can, do it to this, level of accuracy, because you have to model the moon at such a high resolution that it's not easy. Plus, it's done in a real time, and there is not a supercomputer, behind. It can, be done on your laptop, in fact. So it's not an easy, operation, and there are so many things that can go wrong that it doesn't make your life easy. So you see the displacement of the umbra between second and third contact. Okay? So, this is when you use... Yes, Chris?
Just back one or two screens, it doesn't matter. When you have the local circumstances data,
yeah,
the times you display
yes.
are UTC, as
yes.
you've shown there.
Absolutely.
If, like a number of us that travel all over the globe,
yeah.
often we can't remember what local time is.
Yes.
Is it possible to add at a later stage to mouse over the UTC?
You have in fact a tool there, which is giving you the local time. So you activate the tool by clicking on it, and then you click on the location, and it's going to display over here the offset. But I prefer to keep UTC time because it's universal, and also because it can the time, if you change the time zone just by crossing the time zone line, well then the time is different. So it's very difficult to manage otherwise.
I thought you may be able to just mouse over, and internally it would then calculate the offset between UTC and the local time zone, so that you could then, it would just display in the time column.
It could be done, but there are many cases where it's going to be difficult, and it could even create errors sometimes. And so it could lead some people. So in a way, I prefer to let the visitor figure it out on his own, because that data is for certain correct. Then it can have also an indication of what offset should be applied. And then if the person says, okay, no, there is a mistake, can fix it. Otherwise, if you provide the probable local time, but if it's wrong, there are many people, I think, that would see nothing, and they would, of course, miss the eclipse. which would be in a way, a bad thing. But I understand it's a difficult, if the time zones were, perfectly, straight lines, no exceptions, okay. But this is not the case. So it's a difficult subject.
Thank you.
So yes, the geolocation. So this is an example for, in fact, next August. But you see, you just activate the tool on the smartphone, and it tells you, where you are and where you should move. In fact, the direction, you have, and the distance you need to travel. So it's quite easy, to do it. So now I'm going to show you two examples of why it is important to know exactly what is the terrain around you. This was in Antarctica, so I went there in 2003. There was a total eclipse. It was the first, in fact, in mankind, at least the first, during which we could, go to, because the previous one was in the 1918, I think, so it was impossible to get there, at that time. And this eclipse was also very particular because it did occur during the midnight sun. It's not going to happen again in maybe 1 million years. So we decided to, of course, travel there. But what some people, did not take into account is that Antarctica, you have rocks, bedrock, below, but over it you have an ice cap. But the ice cap, it's like a dome. It goes from sea level to over 3,000 meters high. Okay? So, and of course during an eclipse, as you can see, you have to look more or less south. So you're looking toward the highest point of the dome. So if the horizon is too high, the eclipse is behind and you don't see it. So with the terrain elevation profile, it's going to tell you if you can see it or not. And it's extremely accurate. I'm going to show you then 2010 in El Calafate. But this was the first time I used it. At the time it was not for the public. Okay, so it was only for my own use. But then I released it for the public. But what you can see is the picture, the real picture. This is the ice horizon, and this is of course the eclipse. Okay, so it's just barely over it, and you see it does match the computations. And this is the whole the whole eclipse. As you can see, it was like a bird flying over the ice. Okay, and of course the moon is moving in the reverse direction because you are south. Anyway, it was. For me, it was the nicest eclipse ever. And I think it will remain that way. So now, El Calafate. The same thing, real picture, computations. It does match. So, people that, for example, decided to stay in town, in El Calafate, they could not see it because they were too low. The eclipse was behind the Andes. So you had to go to higher grounds overlooking El Calafate. And I'm going to show you. Okay, that picture you see is already cut by the Andes. But there is worse. And this was done by professionals. Okay, there is no sound, but there is sound. I prefer to remove the sound because you don't want to hear it. So look at what happened. So they had the perfect sky, but they didn't see anything. Yeah, well, yes. It's better than nothing. I agree, but
so people was under the shadow of the mountains.
Yes.
Not of the moon.
So you see what can happen, okay? Personally, I think when the sun is low over the horizon, it's nicer, okay? But that's a personal opinion. But it's also, more risky because you have more chances to have clouds, and of course you can have, such issues. So if you don't plan in advance well enough, problems can happen. And again, this was done by professionals. And you see they're looking backwards, and at one point you see the top of the mountains with some light, which means it's light, from the sun. So it means that if you were at that location, you would see it. Anyway, that was completely crazy. I mean, I cannot even understand that professionals,
That professional made that video for you.
But the worst is that I told them, they did not believe me, but that's their problem. But I'm sad, for the customers, because they pay sometimes a lot of money, and in the end, okay, you have the perfect sky, but you don't see anything, or not much, or not what you came, for. Anyway.
Actually, Xavier,
yeah.
That is a total eclipse because the sun is completely covered.
Yes, it is, behind the mountain also. The fact is, when I say on the map, there is no eclipse. There is really no eclipse on the north and the south. But when you, it can be, yeah. Right there, or there is absolutely no eclipse. But here, you do have an eclipse, but part of it is under the horizon. The same on the other side. Okay? So this is, why, you have this, yellow curve. Outside, no eclipse at all. There, some eclipse, but only part of it is visible from the location. For most people, it's not important, but it's a nice illustration of what we said. Yeah.
The sunrise is already eclipsed.
Yes, correct.
Sunset.
Okay, those two slides, I just show them because it's the tool that you use to generate any eclipse map you want. So you can just type, it's over, from minus 2000 to plus 3000. I have a tool that also, does even a larger, time span. But for most people, this is, the most useful time span because you can do historical study and see also in the future what's going to happen. So you just have to, enter the values, search, and then you select, one or multiple eclipses, and you can, create the maps or Google Earth files that you can use in Google Earth. And you have also the possibility to, on that page, to enter some coordinates and ask, okay, which eclipse are going to occur at that location? So I did it, for example, for Esquel. And so the next annular, this is it. So Claudio, did talk about it yesterday. So this is 2017. So I guess for most of you, you should be able to see it. And the center line is really close, to Esquel. So, and then the next total. So of course, that one is a bit more difficult because it's nearly 100 years. So for most people, I guess, not possible. But you never know. That's it. That's it. So as you can see, you can predict, well in advance what's going to happen. I'm not going to really, enter into the details, but the Earth rotation, the speed varies. So, of course, you make a prediction, but you don't know exactly, how the Earth, is going to behave. So it means that the path can be slightly shifted, east or west, depending on the variations of the rotation of the Earth. Okay, but anyway, it's not going to change, by more than a few kilometers over 1 century. Over millennia, yes, it can, but otherwise, the difference is not. And if you are near the center line, it's not going to make any difference. You will still be more or less near the center line.
You can choose the T.
Yeah, you can also. Yes.
TDT or
you can modify one parameter. Yes, you can do that. Absolutely. For most people, I recommend not to do it unless you know exactly what you're doing. But yes, to see the influence also you can do that. Now we are going to come to the lunar limb profile, which is going to be important, in fact, for next Sunday. So, for example, this drawing is made within my software from, in fact, satellite measurement on the moon. You can recreate exactly the shape of the moon. Okay, so it's only part of it, but it shows the level of details that we can have. Okay, it's about 100 meters. So of course, since the moon is quite far away, it's really, really tiny. But what I mean is, we are able to know, for example, there is one sun ray going through this small valley. It's possible to do it, and I will show it after. So this is done now in real time. So this is a representation, a diagram made for the public. So you can access this by clicking on this RC column header link that I showed you in the local circumstances on the Eclipse map. Okay. The other graphic before was done with my software that is specialized, but that is available for the public and is usually sufficient. So you can see this is in fact for next Sunday by the coordinates. I think it's Facundo, that one. Yes. So as you can see, Facundo is near the center line. You have second contact, third contact. And you can see it's nearly symmetrical. When it is, it means that you are close to the center line. Okay? I'm not going to, again, enter into the technical details because there is no point. But what you notice also is that you have, some people will tell me, oh, two contacts. What is it? You have one, the C3, it's the uncorrected contact, meaning smooth moon. The C3 hyphen is the corrected contact, taking into account the lunar mountains. Okay? And as you can see, they are not exactly the same. And sometimes the offset can be quite big. The yellow part, of course, is the sun. So you see that there are some deep valleys, even deeper there. So of course, for the general public, I mean, the zenith is there, so you should even rotate if you want to just look naked eye. Okay, because the celestial north. So if you have a tracking mount and you have your camera on it, this is the celestial north. Okay. So what else can I say? You see that, I mean, the moon is really it's not smooth at all. Of course, it's exaggerated because you want to show how deep the valleys and the peaks can be. So this is Facundo.
How many times is it scintillated?
Sorry?
How many times is it?
It's 15 times. So now we are moving closer to the northern limit. As you can see, the contacts are getting closer. Okay? This means that you are getting further away, from the center line. If you were going to the southern limit, they would move on the other side. Again, it's center line means symmetry, more or less. If you go to the limits, then there is no symmetry. And of course, if you are on the edge, they are going to be just barely, close together. It's never, of course, exactly the same because it's not smooth. But I'm going to show animations of what you will see on Sunday. Because this is, of course, static, but it does help position yourself maybe sometimes, to take a decision, to take, nicer pictures, to observe a phenomena, whatever. So this is, to compare, both. So you can see the variations, between center line and a place closer to the northern edge of the path. So this is my specialized software. It's only for Mac. So this does all the computations at the highest possible accuracy. And it controls also digital cameras, CCD cameras. It's also the software I'm using for Eclipse flight. So it is tracking real-time a flight, so constantly updating, in fact, all the computations, and it's even guiding the aircraft to optimize, in fact, the view that you have of the Eclipse. Okay, so this is, for example, the software I used in 2013, 2015 for the Eclipse flights I did. Now I'm going to show an animation. So you have, it was in 2013, you have pictures of Baily's beads. It was a total eclipse, so not exactly, of course, what you will see next Sunday, because this, you could see it naked eye. But what I want to show is how well the simulation there matches the pictures. And those pictures, they are taken, I think it's every 1/5 of a second. Same on the other side. Oops. Can I play it? You see the moon did the old jump because I moved forward in time. So this, I have been doing it only from 2009. Okay, it did improve, of course, since that time, but so again, it's fairly new. It's the only program I know in the world doing it. And it matches absolutely perfectly any eclipses. I have studied eclipses even in 50 years ago. It matches perfectly. So I know it's it's real. I mean, it's not it's not a coincidence. The fact is, professionals are using it all the time. And I'm going to give an example of an annular eclipse. So same type that you will see, next Sunday. The only difference is that your eclipse is going to be less deep. So the ring is going to be a bit thicker, but slightly bit. Those pictures is what you would see on the left. It's what you would see naked eye, yes. No filters. In your case, you will need to use a filter. Okay? And on the right, the simulation. I didn't, provide all the details, but as you can see, it does, match. It matches so well that, for example, for those pictures, the person that took the pictures gave me a wrong location. And I said, you could not be there. And I gave another location that was, I think, 30 kilometers away. The guy said, you're right. That was the place. So, from the simulations, you can even know if somebody gave you the correct information or not. So, those sending me pictures, don't lie. I will know it. Please give me, the prop, so we don't lose time. But, again, it was interesting because, of course, that person, it was completely unwanted. I mean, that person thought that that was the location. it was written on a piece of paper because 1984, of course, it's a long time ago. So then that person had to check. But that's life. So anyway, it was a good, experience, and I'm happy, that of course it did, match. So now we are going to speak about the annular in 1999. Why? Simply because it's the same Saros. You have cycles. Eclipse, comes by cycles. Okay. Your eclipse next Sunday is of Saros 140. The previous eclipse in this Saros was in 1999. Those Saros cycle, it's about 18 years. So 99 plus 18, 2017. The only main difference between the eclipse in 99 and yours is that yours is going to be a bit less deep. So a ring that is a bit thicker. But that's about all. The rest is nearly the same. The shape of the path, it's just shifted. Those pictures were taken in Australia, and the path, 18 years after, is shifted by about 1/3 of the Earth. Okay, so the next time it's going to occur, let's say in Africa, most likely. So what we saw in 1999 is more than likely what you're going to see this time. Slightly different, but the difference is not really big. Again, picture and simulation. As you can see, it does match. One thing I need to mention: those pictures were taken. Well, that picture was taken without filter, without solar filter. Unless you know what you're doing, I don't recommend you do it. Okay? Of course, the good point about doing it without a filter is that you can see the chromosphere. This, you will not see it naked eye. Okay? But it's possible to have it, on pictures. But unless you really know what you're doing, be very careful. Okay? Because, okay, you're not going to get, maybe, blind if you just do it in 1 second, but still, you can harm, your vision. So, and you can, of course, create, issues, with your camera equipment as well. So, I would recommend not doing it. Plus, that you can only do when you are close to second contact or third contact. Don't do it, of course, 10 minutes before or 10 minutes after. It's really, in the seconds around second or third contact. So we are going to see another one. So again, this you should be able to see. Another one, wide angle. That one is, from Daniel Fisher, which, okay, what I didn't say is that, okay, those two, they were taken near the center line. So, near Facundo, this is what you can expect, okay? The one from Daniel Fisher was taken close to the northern limit. So again, you see, those, beads, bright, beads, and some chromosphere, in between. Exactly, matching the simulation. So now we are going to simulate what you will see next Sunday. So let's try to play it. So this is without filter, and then I will show with filter.
Is that on the same line, Javier?
That one is near the northern limit. Okay. Near the center line, you will have less beads in duration. The advantage of going near the edges is that the beats have a longer duration, okay, because you get them, from second to third contact. It's nearly, continuous. When you go to the center line, you have a few beats for a couple of seconds, then you have the ring, and then, in your case, about 50 seconds later, you have again beats for a couple of seconds. If you go closer to the northern or the southern edge, then you can get beats for 30 seconds, depending on your exact position. But on average, that's what we are looking at. We always also try to see at least a couple of seconds and have the ring. But it's not mandatory. But if you want to optimize beats viewing, you have to go to the edges. Yes, if you prefer to have a nice, symmetrical ring, more duration, closer to the center line. It's fairly, binary. You cannot have both. I mean, it's not possible. So, if you want more beats, you lose duration for the ring. If you want more duration for the ring, you lose less beats and less duration for the beats. You cannot have both at the same time. Not possible. So you have to make a choice. So this is with a filter. Let's start here. So I mean, you see some small bits of the sun in between the peaks. It's quite difficult to see, but and as you can see, it's like the moon is rolling inside the sun. So it goes, of course, from second contact to third contact.
Magnitude is decreasing.
Yeah. Yeah. So then, this will be without filter from the southern limit. As you can see, the beats are different. Simply because the shape of the moon is not the same to its north or to its south. And again, with a filter. So of course, to be able to really see the beads, you need to have some high magnification instrument. So a good telescope, a good telephoto lens, numerical zoom cameras can sometimes do a fairly reasonably good job. But anyway, it's if you want to really have the fine details, yes, you need to zoom in. So this is what you will be able to see next Sunday. So any questions? Any?
Come on. You said that.
Thank you. You said that your high accuracy software takes into account the atmospheric refraction.
Yes.
I assume that you use some standard model atmosphere for that, but there are usually some deviation from a standard model atmosphere, some strong deviation. How does this affect your calculations?
So the answer is I'm not using a standard model. I am using a different model depending on the location, the time of the year, so the season. So I won't enter into the details, but there is a specific module that takes care of this. So it's not a standard model. It takes also into account the elevation, if you are doing it from an aircraft or not, because then it's also different. Yeah. So everything is taken. It's both location, time, season, elevation, if it's, when I say elevation, is of course elevation on Earth, but also in the air.
So the only thing that are left.
The only things left over are local weather circumstances.
Yes.
That's anything that could be very local in time and,
Yes.
and space.
That you cannot predict.
Okay, thank you.
Yeah, I mean, for those computations, it does, match, perfectly. I mean, it's quite, accurate nowadays. Of course, there are always, things you can improve. Yeah, there are some circumstances sometimes that, I mean, there can be issues. I mean, there are also, some bugs. The fact is, I'm happy, when people tell me, okay, well, are you sure that this is correct? I mean, please do. I mean, if you find, anything that is looking strange, I mean, just send me an email. I prefer to know about it than discover, the problem later. Okay, some people say, no, there are no problem in my software, everything is working. I'm not saying this. It's not perfect. The only thing I can say is it's trying to do it as, great as possible, but I know there are some issues. I know some issues, some limitations. But yeah, I always try to improve it. What you have to understand is this is not my job, okay? So I'm not being paid for doing it, okay? I do that on my free time, even though it's the best software that is available. Even the professionals, don't have such a software. Yet, I'm always trying to improve it. Okay, it's let's say a big hobby, and anyway, sometimes you need to do it in the best possible way. Any other question? I can also demonstrate the software if we have a couple of minutes. Okay. Yes.
Can you, at some stage, I don't know whether you've got them off the top of your head.
I'm just asking for people doing photography, what is the best camera settings that you can use, because it's totally different for doing normal total solar eclipses. Can you give us the what your settings would be, please?
Yes, to know exactly which setting you should use on your camera. I will give you an address on my website. There is an online calculator, so you can know exactly what you should do with your camera. My software also has a display for this. I mean, in general, you should always use your camera in manual mode, so to have full control over it. Keeping the aperture always the same, and then of course the ISO as well. For an annular, of course, I mean, just use a standard ISO. I mean, let's say for example 100, 200, depending on the cameras, but don't use 1600. You're not doing astrophotography, okay? So you don't really care anyway about the noise, but so regular setting, and then of course you have to adjust the shutter speed, okay? For an annular, no matter what, you're going to use a solar filter. So it's going to be, I mean, a fast shutter speed. Unless, of course, you go high in the ISO, whatever. So I will try to, of course, I don't have internet there, but I can provide the link. Anyway, I can show it in my software. The problem is, of course, the window is a bit small. How can I do that?
And just while you're setting that up, does your website calculator allow for non-filter
Yes.
images for angles?
Yes. I'm giving an example. Okay. The presentation on the website is very similar to this display. The only difference is that it's available, of course, through the internet. So anybody, even if you don't have the application, you can use it. So you just select the type of filter you're using. Usually, people use filter that we call ND4, ND5. It's the filtering power. Okay, so ND4 10,000 times, ND5 100,000 times. So, as you can imagine, of course, one of the reasons why, for example, regular solar glasses, for example, are not good enough, it's because they don't filter enough. But right now we are speaking only of visible light. But the main issue, in fact, with solar rays, it's not visible light. It's ultraviolet and infrared. Okay, and those solar glasses, the regular ones, of course, they don't filter those wavelengths. So this is why it's dangerous. For your vision. This is why you need to have those special solar filters or special Eclipse glasses. So anyway, depending on the filter, the type of filter that you bought, you select one of the two. Then you select the ISO, the aperture, and it's going to give you, and you can also enter the elevation of the sun, because of course, when the sun is close to sunset or sunrise, the atmosphere is filtering the sun. So it means that you have to, in fact, increase the exposure time. Okay? So it gives you the shutter speed that is suggested without the adjustment and with the atmospheric extinction as well, taking into account what you enter there. So then you just, set the camera to this exposure. I would always recommend one stop lower, one stop over. So that way you can, choose which one is the best afterwards. Or you can stack the pictures. Then it's up to you. But anyway, it's quite simple. There is not much to do. But as you can see, with some regular settings, whatever, it's a fast shutter speed. If you set your camera to, let's say, 100th of a second, this is not what you will get. It will be so bright that you won't see anything. And in a way, anything I would say with regular settings under, let's say, 1,000th of a second is not going to look good. It's unlikely. But of course, if I switch to the ND5 filter, as you can see, the exposure time increases a lot. Okay, because it filters 10 times more. Okay, usually the solar eclipse glasses, ND5. The ND4 is usually a photographic filter, only meant for photography, not for visual use. You can of course use it, but the problem is it's still a bit too bright, so you're not going to harm your vision, but it's a bit too bright, so you will see less details. But for photography, usually ND4 is slightly better. It gives you more latitude, in fact, adjusting the settings. Does that answer? Okay. And so, anyway, if you go on my website, even without the link, you will find, the web page that displays this. So I'm going to show. So, okay, this is Facundo. So I'm going to. Okay. So this is the lunar limb profile, high details. Okay. It's too bad I don't have a bigger screen, but so as you can see, it's very accurate. Even the small details on the moon are taken into account. And I'm going to show you the progress from the last 50 years. Okay. So, the red curve is the watts, the original watts profile. And the mauve blue curve is the lunar reconnaissance orbiter, so the latest achievement in probes, around the moon. So as you can see, the level of details is absolutely not the same. Plus, there are some quite, huge differences. One has been done, the watts has been done manually by, visual observations using telescopes on the Earth. The other one has been done by an automatic probe. Yes? Okay. So anyway, you see, there, okay, it's in a way smooth. No, in fact, it's not. So before it was not possible to predict, for example, beats over there. Now it is. It's nearly impossible to do any better. At one point, it doesn't make any sense because the moon is too far away. So unless you have a huge telescope, you will not observe those details. So even with a nice telephoto lens, this is perfectly sufficient. There is no way you can detect anything that is more accurate. No way. And as you can see, this is computed in real time.
In real time?
Yes. If I change the location, the profile is going to change. And I'm going to show an example. I'm going to change. The moon is not always showing exactly the same face. Okay? It wobbles a bit. Okay? What we call the librations. So you see more or less about 60% of the surface of the moon. Okay? So by default, the program is going to select the values for the eclipse and for the location that you are at. But you can change them. So I'm going to change them. Did you see the small variation? Okay. I made a small change. But anyway, even small variations can change the beats, can change the contact times. Sometimes only a couple of tenths of a second, but sometimes by a couple of seconds. It depends on, of course, the profile. I can also maybe change the other one. See, this is already a bigger change. Okay, so you saw the time it took to compute it. And the fact is, it did compute two. The old, original one, and the latest. So this is, the type of tools that we can use, on a daily basis to take decisions. What can I show? Yeah, I'm going to show maybe this. Although the screen is so small, but anyway, yeah. What time? The problem is I cannot, a bit difficult, but okay, it's at the beginning of the path. I need a bigger screen. I'm trying to show. So this is the shape of the umbra, at the beginning, in fact, of the eclipse. As you can see, it's an ellipse, but elongated and a bit curved. And as you can see, it does, compute where the aircraft, should be, positioned. Anyway, and you see, the umbra, the shape is, changing. So what happens is, when I'm doing an eclipse flight, this can be done in real time. It's, connected, okay, to to the aircraft, controls, and it's giving indications to what should be done. So I think my time is up.
Yes, I will ask you if you agree, because we asked Claudio to make a short summary of your talk, but in Spanish.
Okay.
Okay, for the people who doesn't speak
can.
English. Do you agree?
Yeah,
Well,
yeah.
first of all, thank you very much for your talk. Pedimos a Claudio, que es especialista, nosotros no lo somos, que haga un breve resumen de la charla de Xavier en castellano, para aquellas personas que se perdieron algunas cosas o no se animaron a preguntar. ¿De acuerdo? No va a ser más de 10 minutos. Hay un pequeño cambio en el programa porque, claro, con motivo de la llegada tardía del avión de Xavier, Néstor lo va a recibir, y lo que vendría inmediatamente después de esta charla es la mesa redonda en la que Néstor es el coordinador. Así que después que Claudio haga su breve resumen, Charles Fulco va a dar su charla. No vamos a hacer la mesa redonda, él va a dar el final de su charla, y cuando termine nos vamos al coffee break para esperar a la gente del aeropuerto, ¿de acuerdo? Y ahí va la mesa redonda y la conferencia final de Xavier. Son los cambios que no vamos a evitar. Así que
Bueno, me han pedido que haga una breve explicación, muy breve explicación de la charla que ha dado Javier, para aquellas personas que por algún motivo tienen alguna dificultad para entender, la totalidad de la charla. Va a ser muy breve y con seguridad que se me van a saltar muchas cosas, pero voy a tratar de concentrarme en aquellas cosas que me pareció que son importantes que ha dicho Javier. De todas maneras, acaba de ofrecer para distribución general, para el que quiera, toda la charla que ha dado, digamos, lo que ha presentado en la pantalla, lo que hemos visto en un documento PDF, para que cada uno lo tenga, y bueno, de ahí puede seguir investigando el tema, ¿no? Bueno, de lo que ha hablado Javier es de la construcción de los mapas de visibilidad de eclipses totales y anulares, una programación propia de él, y creo que es única en el mundo, no hay otra, y de algún programa sofisticado o aplicado específicamente para la fotografía del evento del eclipse y de las llamadas cuentas de Baily. En la primera parte ha mostrado algunos ejemplos de mapas donde se ve el recorrido, digamos, donde se ve toda la zona de visibilidad del eclipse, marcada, resaltada la zona donde el eclipse va a ser anular o total, en el caso que fuera un eclipse total, con cierta codificación de colores, que por ejemplo en la banda de anularidad los límites externos son rojos, la línea de centralidad es, creo que celeste, y luego los límites externos que eran verdes. A los costados de los gráficos habían dos figuras en forma de, no sé si decir de gota, porque no es de gota, pero alargadas, una elipse alargada en punta, que son los lugares donde el eclipse sucede a la salida del sol o a la puesta del sol. Entonces tienen una presentación distinta a esos lugares donde el sol está ya arriba, ¿no es cierto? Se lo ve bien en el horizonte, bien bajo, ya sea con el sol eclipsado, cuando está saliendo, o con el sol eclipsado cuando se está poniendo. Y mostró algunos ejemplos de las dificultades que hay en esos casos para verlo, porque si hay un horizonte con montañas, uno puede perderse el fenómeno porque justamente no ha previsto esa circunstancia, y cuando llega el momento del eclipse, el fenómeno sucede detrás de la montaña, como mostró en una grabación de un profesional en el Calafate, todo esperando, y me quedé sin verlo. Bueno, eso en cuanto a los gráficos, a los mapas. Esos mapas, en su propia página de web, hay un enlace donde uno puede elegir el eclipse que a uno le interese en un rango de 4.000 años, desde el menos 2000 al más 2000, no, hasta el 3000, son, claro, el catálogo, el 5 milenios, son 5 milenios. En ese software uno puede elegir el eclipse que está interesado y tiene opciones para hacer uno mismo el mapa. Lo puede pasar a un archivo KMZ y pasarlo a Google Earth y simplemente ver el mismo mapa que está mostrándole acá. Además de eso, cuando uno hace clic en determinados lugares, puede tener una ventana informativa con datos específicos de lo que sucede en ese sitio. Hora de comienzo, ángulos con que, digamos, puntos sobre el sol donde la luna toca, primer contacto, segundo contacto, el momento del máximo. Creo que también tiene azimut y altura, eso no lo recuerdo, pero casi seguro que está. En fin, hay una serie de información que uno obtiene simplemente haciendo clic. Después mostró, bueno, hay una ventanita allí donde da la duración del eclipse, con dos números muy parecidos, pero con algunos segundos de diferencia. Uno de ellos es la duración del eclipse, considerando que la luna tiene un borde suave, no accidentado. Y el segundo número, que puede ser menor o mayor que el de la luna suave, es un cálculo hecho considerando que la luna tiene valles y tiene montañas. Entonces la luz del sol puede estar oculta por una montaña o puede pasar a través de un valle y llegar a nosotros. Entonces, en ese caso, el tiempo de duración del fenómeno se va a ver modificado, en más o en menos, según donde esté. Y esos eran los dibujos que mostró allí con un disco negro y todo un contorno accidentado, donde estaba la topografía lunar, vista desde un determinado lugar de la Tierra, y por supuesto con la altura exagerada 15 veces para poder ver efectivamente el relieve, si no la vemos como una línea. Y finalmente mostró un software específico para aquellos que están interesados. Bueno, mostró lo que eran las cuentas de Baily, y para poder fotografiar el fenómeno con las cuentas de Baily incluidas o no, él tiene un software particular que tiene acceso, digamos, no tiene acceso por la web, donde poniendo o seleccionando distintas características uno puede calcular el tiempo de exposición, digamos, de la cámara, el tiempo, lo que se llama velocidad de disparo, con la sensibilidad correspondiente de la, no sé si decir película ahora porque es digital, pero con el equivalente. Bueno, y una serie de parámetros que uno puede elegir para calcular el tiempo o la configuración óptima para tomar esa fotografía. Bueno, eso entre subidas cuentas es lo que ha contado Javier, y ha puesto a disposición de todos nosotros esta charla en un documento PDF, que enseguida lo va a hacer y bueno, quedará a disposición de nosotros.